See if we can actually get something done today. Huh. You know? You know those days just like run away from you? It's one of those days. Anyway. We're adding a damage system to the roguelike game today. So, as a reminder, this is where we're at. And I still haven't gotten around to putting this on GitHub yet because planning and time management, who's good at that? Right, it's arrow keys, not WASD. No. Yes, we can move around, we have enemies, and there's text that indicates that we had an interaction. I've kicked the orc, much to its annoyance, although visually nothing happens, but the interaction is logged. And we have a randomly generated dungeon that we can explore. We have field of view, shadow casting, all that good stuff. We have 2 different types of enemies. So today we're adding an actual combat system, kind of. We're going to add health bars. And I took a quick scroll through the tutorial and it looks like maybe also the ability to die and lose the game. So, you know, that should be fun. Alright. So let's get into this. Where's my mouse? There it is. Okay, the original tutorial refactors some code, and we will do so as well, because this is a tutorial based off of a different tutorial. Yeah. It's tutorials all the way down. Some things will turn out cleaner this way. Okay. First, let's start with the action system. We won't really change how we use it now, but in principle the command pattern allows... Oh yeah, I still haven't read about the command pattern. Oh well. Allows delaying a command or action, as we call it here. We only delay it very little, creating an action in one function and executing it once it's returned. That's why we can easily keep track of the entity associated with that action, and therefore can pass it once we call perform. But a better way would be to encode the entity right in the action. So once we have the action, we only need to call perform without any arguments, and whatever action we encoded before just happens. What? Code the entity in the action. Okay. Good afternoon. How is the crafty things going? Also, thank you for posting a reel today. The morning was not happening. The morning did not morning. You know? One of those days. Okay. In principle, the command pattern allows delaying a command or action, as we call it here. We only delay it very little, creating an action in one function. No, wait, I read that already. We passed a game argument into actions before. That was easy, as the game node was the one executing the actions. However, getting that at the time of construction would be a bit wonky. Sure, we could pass a reference to the game to the event handler node. However, we only really needed the game to get access to the map data. So the simplest way forward is to give entities a reference to the map data. Makes sense. We need to know the entity anyway for the action, so that's a good place to put that information. So we're going to mess around in entity script. The seat cushion goes well. Oh yeah, you started a seat cushion, I forgot. It had the pretty colors. get up and do something, so I'm sweeping. Okay, now you're making me feel bad that I'm supposed to also have swept today, and that didn't happen. Why is sweeping stairs the most irritating thing? Like, I hate cleaning stairs, but I love multi-level houses. It's very annoying. Yes, okay. What are we doing to the entity definition? We are creating a reference to map data of the type map data. And then in our init function, positions, we're going to self.map data. Map data. Nope. Data, which means we will be passing in a reference to map data. There we go. And so we set the thing that we're passed, we set that to our self-reference of map data. In our variables, we simply create a new variable to hold the map data, which is filled okay, the first entity is created. The first entity created is the player, and we need to handle them a bit separately. We change how the player is created in the game ready function. Game ready. We are now not doing that. We player's a bit of an odd case as we create it before we create the map. We therefore pass null here. Ah, yes, we're creating a new entity. You're not gonna give me a nice... Okay, fine. Yes, because you want the map data, a start position, and an entity. Or an entity definition, rather. So we don't have map data yet. Start position of 0. And a player definition, which we've created in with like a config file. Okay. Set the map data manually later. Do so in dungeon generator. When we place the player in generate dungeon. Generate dungeon, player. There we go. Room is empty. Or if rooms is empty. New room gets center. Player dot map data equals dungeon. Well, that's a lot of errors down there. We'll get there. In the same script, we also modify place entities. Which is responsible for instantiating new enemies. If can place, new entity, random, blah blah blah. Which means we need to pass in the dungeon and pass in the dungeon. And now those are not angry anymore. Is this actually important? Last minute volunteer rearrangements for tonight, but I don't think it affects me. I get to go and be cheerful and welcoming and sign up for class. Oh, crunch. What do we think of the music today, by the way? I'm trying out a medieval lo-fi playlist on SoundCloud that is theoretically copyright free. So, I don't know, how do we feel about medieval lo-fi? I'm just vibing, don't mind me. What was I doing? Passing dungeons to entities. Okay. Out of the way, we can get to the actual actions we wanted to modify. Go into action. Go into action. And replace it. We'll just straight up replace it with the following. Great. I'm not going to type all that. I'm gonna get rid of these excess new lines. I hate excess new lines. Can't stand it. Okay, so it's just setting our internal reference to whatever entity was passed in. Perform doesn't do anything. And get map data returns the map data for the entity referenced by this action. It's mellow, not too loud or too sad. Excellent. I only tested it a little bit last night, so there's like wait, how many tracks are in this playlist? 142. We've got some music. It'll last us a while. Am I busy tomorrow around noon? I don't know what that word's trying to be. And I are doing help set me set up website stuff. That sentence is not English, but maybe. I don't think I'm doing anything tomorrow around noon specifically. I'm just packing and grocery shopping for the weekend. So I should be available around noon. I can make myself be available around noon for whatever that sentence says. Aw, Phaedra, making everything better. I'm sure it's totally not apparent on stream, but I'm wearing those raven skull earrings from when we did the, I think it was the Dragon Horde yarn order, like last spring. And we got the shawl clips, and I also got these earrings, and then I just like never wore them until right now. Finally getting around to using the thing I bought like a year ago. variable to hold the entity performing the action. We pass this entity and pass this entity during the creation of the action. Form, however, now loses all its arguments. Create a convenient way to get the map data. Now we have to go over all the actions we have and modify them to this new interface. Okay, so escape. Now does not take any actions. And it's entity get tree clicked. Oh, marvelous moderate, got it. Set up for the Etsy shop. Yeah, I can be around to do stuff with that. And action with direction. Has to be initialized with an entity. Is the type entity. Super dot init entity. And we apparently don't need perform at all anymore. So instead we have get destination, which is going to be the grid position of our entity plus the offset. And get blocking entity at destination will be get the map data, get the blocking entity at the location of the destination of this action. Okay. And then we have melee action, I think. Melee action. Takes none of that. No destination. Here we get to use get blocking entity at location to write our code a bit more concisely. Okay, but we don't have this function yet. I assume we're going to get to that. We do some other thing in movement action. We have none of that anymore. And we don't need destination. Don't need game, we just have our own get map data. Destination tiles, map data, get tile, get destination. And if we don't have a destination tile or the destination tile is not walkable, return. Otherwise, get blocking entity at destination. Turn and then move by the offset. Oh, it's not at location. It's destination. There we go. There we go. Because our action with direction has a get blocking entity at destination. Which these other things incorporate all of this plus some other stuff. They inherit these functions. Okay. Movement action. Did that. Bump action. We're gonna get rid of all that. Don't need that. I don't want to retype all of this. So this is saying if get target actor, which I don't know that we've defined that anywhere just yet. Then create a new melee action and do it. Otherwise, do a movement action. What are you upset about, though? Have I done something wrong in movement action? Movement action wants entity and offsets. Oh, I did miss a step, I think. Where's movement action? Oh, we don't even have an it in movement action anymore. We just go straight into perform. Okay. So now is bump action happier? Very slightly, aside from we still don't have get target actor. Yeah, that's the only reference to it. I imagine we'll add that at some point. Let's modify event handler where the actions are generated. First thing we'll do is rename it. And handler class name is overloaded in the internal class of Godot. So first let's rename the file to input handler. Okay. Rename. Come on. Rename. I want to rename. Don't want you to be event handler. I want you to be input handler. There we go. Modify script. Action. Jump action.new player 0 -1. Okay, I don't see what's different about this. Oh, we're adding player in front of all of these. There, there, and there. Oops, and there. So we've changed name of event handler into input handler. Also, we now pass the player into get action. Need to create our actions. Last piece of this puzzle is to modify. Oh. No, I forgot to step player entity. There we go. Our main scene also changed the name of main scene. Rename. Input handler. We now pass the player into get action, use it to create our actions. The last piece is to pass the player into get action, is to modify game. This is upset because it needs to say input handler. We need to, because we removed our camera. So on, ready, get our camera node of the type camera 2D. Referencing the existing camera 2D node that we have in our scene. And then in physics process, we need to there'll be an input handler. I'm realizing I'm deviating slightly. No, but you're input handler, and you should say event. You should say input handler, not event handler. Anyway. Perform. Don't need any of that. Handle enemy turns. We change perform self-player into self-performs. The action already knows everything it needs to perform the action itself. Okay, but yeah, so this wants player entity here so that it can pass it around, which means we need to put it in here. Otherwise, it's not going to work. Okay, refactoring out of the way. Okay, so does that mean this runs again? No, because the fuck is get target actor? What did this used to say? Get blocking entity at location. I think it's gonna have to, I think it's supposed to be that. I think that's actually what they meant. Get blocking entity at destination. So if there's something, yeah. So if there's a blocking entity there, do a melee attack. Otherwise, try to move onto it. I think that's what it's supposed to be. Let's see if that runs. So far, so good. And are we... Yeah. We're kicking the orc much to its annoyance. So... And the escape button works. Okay. We are, in fact, back where we were before. Just with some code that makes slightly more sense. Why are you taking me in things? Is this important? Do I need to know things? No. Not things that are important. They might be important, so I have to check. They are not in fact important. Alright. So now that we've got the refactoring out of the way, minutes in, we can create our combat system, which is actually what we're here to do. And I thought I didn't need a wrist brace, but I totally do. Where did I put it? In this tutorial, we will create our combat system. This will include things like health and dealing damage. This also includes a very simple enemy AI. Ooh, enemy AI. I'm gonna have fun with that. We will do this by composition. Entities will be able to hold several components that extend their... Oh, that's not the right strap at all. Enemies... what? Entities will be able to hold several components that extend their functionality. A fighter component will hold health and similar, and an AI component will handle the actions the enemies will perform. One deviation from the original tutorial that I will omit will be that I will omit the actor class. I wasn't sure which approach I preferred because the other option is to extend our entity class by some functions that don't really make sense for non-actors. However, strict inheritance is also limiting. A fighter component allows an entity to have a health stat, allows it to be attacked by other entities, and allows it to be destroyed. If we wanted to have, say, an obstacle like a barrel or a door, then that's just what we would want of this. If we were to go the inheritance route, we would need to make that barrel an actor, even though it won't act. We won't create things like barrels or doors in this tutorial series, but extensibility is still something I want to consider. Therefore, I prefer to just use composition to give every entity the option to have any component. This means we have to give things like the isAlive function to all entities, but technically we can ask, for example, the barrel is alive. You notice though that I still use the actor terminology in the directory structure just to organize things a little bit better. Okay. So let's start with components. Oh, stretch. Do. Okay, let's start with components. We will start with a simple base component. Create a new script extending node at place. Entities, actors. Create new folder. Components. Oh, did I put it in here? I didn't mean to. Actors, components. New script. Base. Component. Looks like this. Why are we getting parent as the entity? And we have a map data. Sure. Use the onReady variable to get the entity the component will be attached to. The components will be attached directly to entities, so we can just get the parent. Right, we're adding like building blocks to a thing. Also very often need access to the map data. So we create convenience function. Let's create an actually useful component. How about that? Create a new script extending component at source actors, components, new script, fighter, component. Which is going to look like this. So what's this saying? I don't think I did that right. That's better. Yeah, okay. What are you upset about? Cannot find type, fighter component definition. Yes, well, we haven't made it yet. So that's fine. fighter component has max HP, current HP, defense and power stats. And that's all it does. For right now. And this line makes sure that the hit points stay between the values of 0 and whatever the max hit points are. So we can't accidentally give it extra stuff, but presumably we could all add like shields and temporary hit points and all that stuff. We'll use values or initialists from fighter component definition, an approach we already use for entities as well. Tile. You will soon see why this resource-driven approach is especially useful, but first we will need to create that resource type. Create a new script extending resource. Good lurking. So this is saying to create the component definition down here. We have all of our other definitions up here. So I'm thinking I might depart from the tutorial slightly, just for consistency's sake. No, wait. Wait, this is talking about scripts. Never mind, I do want it down here. Components. No, not a scene. Okay, new script. No. Wait. First, I want a new folder. Oh my god. Component definitions. And in here, I want the new script. Fighter component definition. Which just has that stuff. Allowing us to set the stats of our entity. Before we attach things to our entities, let's handle the AI. However, there are a few prerequisites for that as well. The AI will use pathfinding, so we want a system for that. Oh. So we have a script. So our fighter component script is content because we have a fighter component definition script. Okay. Oh, okay, I understand. I think. So the definition files can be scripts, or they can be these resource files. But if we want to define variables that we can set for these things, or define our configuration values for these things, then we need a script. Okay. So it's starting to make sense. The AI will use pathfinding, so we want a system for that. Pathfinding will be the responsibility of map data. So we're going to modify map data a bit. By adding a pathfinding weight, we have width, height, tiles, entities. We're now also going to have references to player and Pathfinder, which we haven't made yet. But it will be a type of A-star grid. I vaguely remember A-star algorithms from university. Vaguely. We had two things at the start of the script. Create a constant called entity pathfinding weight. This is the weight we use for blocking entities. These entities block actual movement, and we want other entities to try pathfinding around them wherever possible. But we don't actually want to block pathfinding through them. Suppose a player flees into a corridor followed by two orcs. If the orc closer to the player would block the other orc's pathfinding, the other orc would seemingly run away from the action while he tries to find a way to the player's position through any other corridor and room. By blocking entities, just increasing the weight for the pathfinding, the orc will go around the other orc when it can, but queue up nicely behind the other orc if the... Okay. The other paths would be too long. Okay. Apart from the pathfinding weight, we also add a pathfinder variable of type A-star grid to D. This version of the A-star algorithm makes pathfinding on a grid pretty easy. So now we add some functions to manage the pathfinder. Register blocking entity and unregister blocking entity. I assume that still goes in map data. Going to assume. So when we register blocking entity, take the pathfinder, set point weight scale. Don't really know what that does. Based on the grid position of the entity and the entity pathfinding weight. When we unregister an entity, we set the points at this position to 0. I think that's what that's saying. The register function tells the pathfinder that the entity is there by setting the pathfinding weight on the entity's position to the entity pathfinding weight, just as we described above. To tell the pathfinder the entity isn't there anymore, we use the unregister function, which sets the weight back to 0. Okay, I was right. However, we still need to set up the pathfinder properly so it knows which tiles are walkable and which are not. So we need set up pathfinding. So this is creating a new Pathfinder? Oh, because up here we're just saying that this is going to be a variable of the type A* grid 2D. We don't actually create one until we set up pathfinding down here. Pathfinder region width and height will be the width and height of the map. We run whatever native update function it has. So then we go row by row. Top, left to right, top to bottom. Assign grid position to that spot. Okay. And then we get the tile there. Don't know what set point solid is, but we set it at the grid position based on whether or not the tile is walkable. And after we do that, then we go through all the entities, and if the entity is blocking movement, then we register the blocking entity. I feel like this whole pathing system is kind of weird, but I don't have a better solution for it right now. Okay, so we set up the dimensions of the map, which requires a call to update. Sure. Go through the whole map. Can't just loop through all the tiles, which is why we have nested loops for X and Y. Treat tile set. That point in the Pathfinder to solid if the tile is walkable. Okay, so this is just telling the pathfinding algorithm which tiles are walkable. See that this kind of setup requires a finished dungeon. That's why we need to call it in dungeon generator at the end just before the return statement of generate dungeon. There's our dungeon generator. Need to call it in dungeon generator. Just before the return statement of generate dungeon. Okay, so place entities, rooms. Just before we return the dungeon, we set up pathfinding. The last thing we need to do is some kind of management of the some management of reflecting moving entities in the Pathfinder. We can do this in our entity script. In move. Ah, okay. So this is saying for the entity moves, unregister. Can't spell. Blocking entity self. And then we move it. And then map data register. Blocking entity self. No, not self, modulate. So we unregister ourselves, and then we move, and then we re-register ourselves. So now apparently we can get to the AI. Start with base AI by creating a new script extending component. Entities, actors, components, new script. Base AI component. And it defines functions that all AIs will have. Which is just getting a path. Okay. Sounds like far too much adulting. What did you miss? We finished refactoring, and now I'm just starting to work on the AI for having things move around. So in theory, when we're done today, things will move around on their own, and I'm very excited about it. Oh, we also added the ability for things to have, like, fighting stats, like HP and defense and things like that. We haven't attached that component to anything, but there is a component that will give things the ability to fight. We have a perform function that will work similar to actions. The original tutorial actually uses multiple inheritance to have the AI also extend the action class, but this will work just as well. We also have a get point path to function, which gives us a path from one point on the map to another using our new pathfinding functionality. With all the work we already did, this is thankfully just a one-liner. This isn't an exciting AI yet, so let's make an actually useful one. Create a new script extending base AI component at, ooh, okay, hostile enemy AI. I like the sound of this. This sounds like actually fun. Entities, actors, components, new script. Hostile enemy AI component. Which I'm not typing all of this out. Copy. Paste. Alright, what do you do? We find the player, that's our target. We get their position. We get the offset between us and the player. By us, I mean this is from the enemy's perspective. We calculate the distance of that. And if the... So if we are currently in view of the player, and the distance is less than or equal to 1, so we're right beside the player, we're going to hit the player. Then we're going to get the path to the player. I don't know what pop front does. I'm not familiar with this pathing algorithm component. And then, so we have a path, and assuming we have a path. Oh, A star generates a number of paths, I think, so this is probably popping off the first most efficient one. Off the stack of possible paths. So assuming we have a path, that a path exists, then our destination will... I guess we get our destination. And if there's a blocking entity at the destination, we wait, which is not an action we've made yet. We'll return a wait action. But if there's not a blocking entity, then we pop front again. Get the offset between our destination and us, and return a movement action. That should bring us towards our destination. And I guess if we're not in view, we just lie in wait. Yeah. I think that's what that's saying. Don't love how this code is laid out. The logic isn't super obvious. But it works. We'll roll with it for now. Okay, we need to store a path. This is kind of the memory of the entity. If the player is in view, it will update the path variable, but if it loses sight, it will follow its current path to the position it last saw the player. Okay. Isn't the entity us? Isn't the entity us? What? Okay. Let's read through this. So starting with this first chunk. Our target will always be the player. We retrieve it and get its position. We then calculate the offset and calculate the distance between them. And diagonally also counts as one step in this instance. Good to know. Don't know if that's entirely fair because I'm not sure the player can move diagonally. We don't have a diagonal move. We only have up, down, left, right. I think. I guess we'll find out. Okay, so then for this bit, we check if the entity is in view of the player. Yes, okay. If the player can see the enemy, the enemy can also see the player. That makes sense. So in that case, we want to act accordingly. If the distance is 1 or less, meaning the enemy is standing right next to the, we'll hit the player. Farther than the way, we pressed a new path from the Pathfinder. We then need to remove the first element of the path because that is the tile the enemy already stands on, and we only want the next tiles we need to go to. Okay. So that's what pop front is doing. We don't need that first tile. Because we're already standing on it. Then regardless of whether or not the enemy sees the player, we'll try moving along the path. If the path isn't empty, so we actually have a path, we get the next tile to move from it. Ah, because path is an array of tiles, so we get the first one because the 0 indexed. Okay, so our destination is the next tile in the path. Of course we need to check whether the entity will be able to move there, otherwise we don't want to consume a step in the path. If a horde of enemies is chasing the player, then they might block each other. If the entity would be blocked, we make it wait a turn. Otherwise, we can use up the next path step and calculate how we need to move, i.e. the move offset, and then create and perform the corresponding movement action. Makes sense. Lastly, if we're not returned yet, by either attacking or moving, we create and perform a wait action. We haven't created that one yet, so let's do that now. Okay. So I was more or less right about what that all does. Create a new action. Is actors' actions. Create new script. Wait. Action. Which doesn't do much. It's kind of a null action. It makes sure nothing happens. Turn our attention to the entity so it can hold and manage those components. For the start, we expect entity definition. Entity definition will now have components, including a fighter component definition and an AI type. The neat thing I mentioned earlier is that this now can be a sub-resource. Whenever we create an entity definition, we can fill this variable with a new resource that we can edit right in the same inspector window. And if we don't want the entity to have such a component, we leave that field empty. This makes it very flexible. We also have an AI type variable. The variable refers to an enum we will create shortly. The reason we don't have an AI component definition is that we will only have a small number of fixed AIs, so we just need a way to know which of these to instantiate. So on to entity script. Extend sprite to D. We have two types of AI. None and hostile. And we need references to the components. Then use set entity type to extract the component information. At the end. Set as the name previously. Oh, wait. Set entity. Oh, we already have it. Haha. Well, we don't need to do that now, do we? There we go. So this stuff we had before, but what is match? Is match like switch case? Seems like. Check which type of AI it should be. If it should be the hostile AI, we create a new hostile enemy AI component and add as a child. Don't handle the none type because it's just nothing, we don't need to worry about it. Then we check if an entity definition has a fighter definition, sub-resource. If so, we take that info and create a new fighter component and add that as a child. And then we just need one more function. Is alive, which if it has an AI component, so the AI component exists, then this thing is alive. By removing the AI component when an entity dies, we can both stop it from doing any more actions and we can mark it as a dead entity. So we don't have to simply remove it from the game, we just take its AI away. We just take its soul away. I feel like there's something philosophical there. Oh. We now can have entities with components, but to actually do so, we need to add these options to our existing entity definition resources. So go into entity definition. Ow. Never mind me and my cracking joints. It's fine. To add these options to our existing entity definition resources. So go into entity definition work. Are you orc? No, you're troll. Orc. We'll see our new components category. Do I? Do I though? saved recently. See our new components category. The easy thing first, set AI type to hostile. Margin, resource, no, don't think that's it. Color is blocking. Mechanics. Oh. It's upset because it can't find AI type under base entity. Did I not? Here's AI type. AI type. Did I spell it wrong? Entity.ai type. Entity.ai type. Don't care. Cannot find a type under. Okay, it's upset because entity doesn't have an AI type apparently, even though it totally does. I've missed something. Get a new enum. Yeah. Set entity type. Oh, did I? No, I did. Set entity type. Yeah, type. Component. You're fine with AI type. Not find type AI type. Why though? Entity dot.
So we are cursed with what we are doing here. So we are cursed with what we are doing here. So we are cursed with what we are doing here. Overwhelming and collective murder. So we are cursed with what we are doing here. So we are cursed with what we are doing here. Overwhelming and collective murder.
Entity has an AI type. It's right there. Copy, paste.
So we are cursed with what we are doing here. So we are cursed with what we are doing here. Overwhelming and selective murder.
Okay, if we just comment this out for a minute so that it actually runs, or compiles rather. But I do get this components thing.
So we are cursed with what we are doing here. Overwhelming lack of order. So we are cursed with what we are doing here. So we are cursed with what we are doing here. It's not that I hate it, I love it. I love it very much. But I love it against my better judgment.
Well, I can at least set these things on it.
And the sky looked like a mess. So we are cursed with what we are doing here. Full of obscenity.
The max HP to 10.
Still prehistoric.
Ooh,
Full of obscenity.
power to 3, defense to 0.
So we are cursed with what we are doing here. So we are cursed with what we are doing here. It's an unfinished country. Still prehistoric. It's not that I hate it. I love it. I love it.
But I can't give you an AI type until I can figure out why this doesn't.
So we are cursed with what we are doing here. So we are cursed with what we are doing here. It's
Am I missing something about AI type?
I love it very much, but I love it against my better judgment.
Got that.
So we are cursed with
Got that.
here. So we are cursed with what we are doing here. I wouldn't see anything.
I'm not there yet. There's only 3 references to this.
Asphyxiation, choking. So we are cursed with what we are doing here. So we are cursed with what we are doing here. So we are cursed with what we are doing here. I wouldn't see anything erotical here. I would see fornication and asphyxiation, choking. So we are cursed with what we are doing here.
Weird, okay. What?
So we are cursed with
I'm gonna close Godot. And then I'm gonna open Godot. We're gonna see if this magically works. Well, it's not red now, so maybe that did it. If at first you don't succeed, try turning it off and on again. So now we have an AI type. Hostile. Okay. I don't know, it works now. Having new company over is stressful? Yes. Good luck. I hope it goes well. Is that today? Or when is that? When is that happening? 6 p.m. today. Good luck. I'm sure it'll be fine. Probably nothing to worry about. On the other hand, if it's a flaming disaster, what a great story. Flaming disasters make the best stories.
So we are cursed with what we are doing here. So we are cursed with what we are doing here. The only thing that is lacking is the diamond.
Alright, where was I at? I was down here. Not helping? Sorry.
So we are cursed with what we are doing here. So we are cursed with what we are doing here. Overwhelmed with growth. So we are cursed with what we are doing here.
Oops.
So we are cursed with what we are
I find it very calming for myself if I know things like, could it go badly? At least it'll be a good story. As long as it's not the kind of badly where like somebody could actually get hurt. That obviously, you know, avoid that. But if it's just like, well, that went well, that makes a great story. I find that comforting. But I know not everybody works that way. More hostile. What are we setting you to? It's recommending 16, not 160. Four and 1. And then we need to player.
So we are cursed with what we are doing here.
And we'll set our... be recommending 30, 5, and 2. Oh, we're even scarier than the troll. Excellent. You might expect though but we can't leave AI type as none because our is alive function would count us as dead, so we'll set the AI type to hostile. This will give the player hostile enemy AI component, but the AI won't do anything. Let me show you what I mean. What are we looking at? Game. Handle enemy turns. We don't have a get actors function yet, but it looks like we'll make that right away. If the entity is alive and the entity is not the player, then we perform whatever action. to explain that I do not want to make the distinction here in terms of class hierarchy. We can create something similar by just returning an array of all alive entities. It seems redundant to check is alive here, and in our current game it is, but imagine if we extended the game in a way which we allow an enemy farther back in the list to die during the earlier enemy turns. It'd still be in that array, but we wouldn't. But when we get to it, it won't be alive anymore, so just make sure we check it again here. Okay. So let's now create that get factors in our map data. Map data. Too many indents. Unnecessary. Okay. So get actors will return an array of entities. Actors is an array of entities that starts empty. For each entity in entities, if it's alive, add it to the actors and return actors. And then get actor at location for each actor. If it's grid position, it's location, return actor. That seems inefficient. If you had a lot of enemies, that could be a problem. Because you're looping through all of the actors just to see if anything's at this particular location, and it seems like I mean, you gotta search somehow. Seems like there might be a better way of doing that. Well, it's still in the oven, so I guess that's fine. Problem with glasses wearing people. You go to adjust your glasses and you stab yourself in the eye because you're not wearing glasses. When glasses wearing people wear contacts, was the rest of that thought. Okay. Now the way we set up our AI pathfinding allows enemies to move diagonally. That's what I thought. The player can't at the moment, so there's no input that creates diagonal bump action. So let us now expand our input system a bit. We'll have 3 ways to move the player. The first is the arrow keys, as before, but we'll extend those by some special keys we use for diagonals. Not the most intuitive, so we'll also use my favorite method, the numpad. Not everyone has a numpad on their keyboard though, so we'll also implement the classic Vim-style direction keys on the right side of the home row. Okay, I'm gonna go mess around in project settings now. Project settings. Input map. Add new action. Type move up. And click the add button. Should see it in the list, yes, and a plus sign on the right. Click that and assign the keys you want for moving up. You can add multiple keys after one another, keep it a physical key code, that way the layout will stay the same even releasing another keyboard layout. Here's the actions and corresponding keys we'll use. These are the ones that make sense. Okay. do that. So we can have up. I'm gonna add WASD because that's what I like. And we can have move down, add, which will have that. And that. Oh, this is just gonna be fiddly, isn't it? Okay, move left. Move right. Move up left. Guess I'll go for Q. That's the only one that makes sense. I'm just not even gonna put all of these in because I don't wanna. Move up right. Be E. I do actually know how to bend an open guitar string. I did play once upon a time. Now whether I can still do it is debatable. Move down left. Wait, bend an open. Wait a second, bend an open string. That doesn't even make sense. Okay, how do you bend an open string? Move down. Let's go for X. That seems fine. Bend it beyond the neck? Bend it beyond the neck. But anywhere you touch the string, wouldn't that affect the note? I'm gonna need a visual. It is... I'm gonna use space for that. And quit is escape. Okay. Now that we've defined all of those in the most tedious way possible, with our actions defined, let's rewrite input handler. Place the code. Replace the code. Fine. Okay, we've got all our directions that we just defined, the vectors they're associated with. All right, explain this here. Create an array that associates the names of the action strings with the desired move direction. This way we don't need 4 more if checks. We can simply loop through the keys of our dictionary of directions. If that action is pressed, we create a bump action with the corresponding offset. We also added a wait action for the player and changed the code for the escape action to use our new actions. Now that both the player and the enemies can move around freely, let's have them do some actual damage. Actual damage. Okay, actual damage. First, we only want to hit living things. For now. So to make that easier, we add the function to action with direction. Get target actor. Which gets the actor at the destination of the action. And then in bump action, if get target actor, go. We need to rewrite melee action. So far, that action has only printed a little statement. We will still print a statement so we know what happened, but now we will also do damage. And I don't feel like typing. Okay, so we get the target actor, and assuming we have one, then our damage will be the power from the fighter component, the power of the entity minus the defense of the target, and then we have better log strings. Which will be entity attacks target for so many hit points, do the damage, or but does no damage. Check general and Discord. Alright. I will check that out later, because it's... Look at my wrist, it's time to go. I do need to wrap this up pretty quick. I don't know how involved the rest of this is going to be, so I will look at that after, because I don't understand how one bends an open string without ruining the note. Because to bend the string you have to touch it, but if you touch it, you're messing with what note it's producing. Unless there's some guitar magic I'm unaware of. I will have so much fun at dance. It's open house night again. It's a whole crop of new people to be weird at. It is in fact officially my job tonight to be weird at people. And by weird I mean welcoming. But the community is comprised largely of the right kind of weird people, you know? You know, the right kind of weird. So if I be weird at them, then it's the test to see if they're the right kind of weird. I will check the channel when I check the channel. Okay, the top of the function is the same as before. The exception that we now use the guitar to blocking entity, then we calculate the damage. A more exciting game would have damage ranges, maybe some simulated dice throws, but here we will just take the attacker's power and subtract the defender's blah blah blah. Okay, yes, got that. Now that entities can take damage, they should also have a way to die. Here we come to a bit of an issue. Where I previously thought it would be a nice trick to have values like is blocking movement, just refer to the entity type definition. We will now want to change that value for individual entities when they die. Therefore, we need to go back and modify entity GD a bit. Need entity name. It'll be when it is. I don't know, later. Oh, it's about to get loud. Hold, please. Okay. Map data. Okay. Now a variable for name and for blocking movement. I would have preferred if I could have followed the convention to name it is blocking movement. But that would have collided with the function of the name. Initialize these values in set entity type. Grab all of those. All our code so far has referred to the functions we wrote to retrieve these values from the definition, so in order to keep all that other code without the need for any further changes, we modify these functions again to now give us the values directly. Like so. We need a visual representation. That's a sentence. We need a visual representation for a corpse. For that, create a new resource of type Atlas texture. What? Ugh. Okay, no. I do not have time to finish this. so we're going to have to leave it here today. Oh no, I lost my spot. Representation for corpse, that's where we left it. Okay. But in theory this runs, and in theory I can do damage to things. Oops. Or I've broken something. Cannot assign value of type node. To variable input handler was specified, type input handler. Alright, this is a later problem. Anyway. Shit's broken and I don't have time to fix it. Anyway, thanks for hanging out. I gotta wrap up. There will be no stream on Friday because I will not be here. I'm at a dance competition. So there will be no stream until next Wednesday. Woo! Punch the microphone. Next Wednesday, 3 p.m. Eastern, doing more of this. Visual representations for corpses. Yeah. Wait. Hang on, actually, let me check my calendar. Yes, okay. Some stuff is happening next Wednesday, but so the stream next Wednesday might be a touch earlier just to make everything fit in the day the way it needs to. Anywho. Greek cursive. Fancy. Yeah. So you won't miss corpses talk. Yeah, it should be fun. So I will say, see you next week. For corpses. There's no... kind of an outro is that? I don't know. I know everything I can think of saying is just getting progressively worse. So you know what? It's fine. It's fine. It's fine. See y'all next Wednesday. Bye.